I'm Anil Kumar, and I'm glad that all of you have joined me to learn advanced functions. As you know, this is a prerequisite for calculus, and our idea here is to learn all the concepts and also see how do we move from here to calculus, correct? Till now, we have learned basics about the functions. Last class was on parent functions. Uh, is everything clear up till date, or do you have any doubts? Okay, so I'll assume that everything is clear. Parent functions, once you know them, and the key points. And then today we are going to learn about transformations. So if you apply transformations on the parent functions, then you can sketch any graph. Or if any graph is given to you, it will be combination of those parent functions and their transformations. And therefore, today's lesson is extremely important. I know you all have done transformations earlier, but see how I look at it and how you will be looking at it after today's class. I'll share with you the questions or the lesson which I have prepared for you. Can you all see my screen, please? Okay, your mics are muted and therefore I cannot listen to you. Now, we can move forward very quickly provided you give me answers, one after the other. I need quick answers. Within a minute, one question should be solved. And only then 15 questions can be solved in 15 minutes. Otherwise, we'll be taking an hour doing all of them. Okay. So unmute your mics and then just participate actively. If I am not asking anybody to answer in particular, any one of you can answer the question. Perfect. The idea is that, I should be communicating with you and understand where you are, correct? Now, this particular page is basically on transformation of functions. So we'll be looking into a function's transformation. I've written it in function notation. So if I have f of x, that f is my parent function, okay? And the transform function is g of x. And right here, I have written a f of k times x minus p plus q. You will notice one thing, that this part is inside the bracket. Do you see? This part is inside the bracket. Now, this is all the operations which are performed on the function, which will relate to horizontal transformations. You get the idea. So the term k, which is inside this bracket, really leads to horizontal compression, stretch, or a reflection on the y-axis, which is also kind of horizontal. Do you see that? Perfect. Now, if the value of k is greater than equal to 1, then is it stretch or compression? Tell me. Tell me. If k is greater than 1, it is a stretch or a compression?
Compression.
It is a compression, right? So inside parameters work kind of in a reverse way. And if p is positive, in that case, we are moving it to the right. So that is all horizontal translation. On the other hand, we have these parameters which are outside a and q. A leads to vertical stretch, compression, or a reflection. If a is negative, then the graph will be reflected on the x-axis. If a is greater than 1, in that case, it will be a stretch by a factor of a. But if a is between 0 to 1, in that case, it is a vertical compression by a factor of a, correct? So we say normally 1 over a, correct? Now, I have written it in the absolute function notation. So when I say absolute value of a is greater than 1, then, we could have had minus 3, for example. We're looking at the absolute value, which will be 3, correct? So that 3 will lead to a vertical stretch, correct? Minus, on the other hand, will give us a reflection on the x-axis. That's very clear, right? Now, other part of this is always looking into the original point and what happens to this original point when we perform the transformation. It is called the image of that particular point. Most of the time, the original points will be the key points, key 5 points, which we learned in all the functions, correct? Parent functions. So you have to compare your points with respect to your key points, which we learned in the parent function. Now, if a transformation is given to you, you can apply the transformation on each and every one of those 5 points and get the transform points. Joining the transfer points, you get the graph of the transform function. Is this part very clear, right? We'll take a few examples now. And I'd like you to really answer my questions fast because they are very simple and I know that you can answer most of them very easily. The very first one is a parabola, correct? So we have two graphs here. One is the green graph, which is x squared. Now, x squared is my parent function, as you know. It has been transformed. And the function which we have got is uh, shown in red. Can you tell me what is the equation of the graph in red and what is the transformation?
So the graph would be y equals to x squared minus 4.
Y equals to x squared minus 4. That will bring the graph only 4 units down, correct? It has also translated, correct? So what should it be? Yes. Translated 2 units.
It's going to be y equals bracket open x. Wait, in the bracket, does the
Yes,
it's going to be x minus 2 squared and then plus minus 4.
correct. So that is how it is. You can see that it is a pure translation, right? In translation, the graph is exactly congruent to the previous graph. Do you see that? So if the two graphs are congruent to one another, in that case, we know there is no stretch or compression taking place. That is a very key point to understand from here, right? So here is your answer. And the key point here is to understand that if they are congruent, that means only reflections and translations have taken place, no stretches and compression. So you only look for how does it move, right? You could move 2 right and 4 down or the other way. Either way, you will get your equation, correct? Inside, as we did x minus 2, do you see it is inside? Inside led to horizontal. Do you see that 2 units? And outside led to vertical. So that is how easily we get our equation. Absolutely clear to you, right? Question number 2. It is slightly difficult. Again, the original graph is square root of x and it has been transformed. Can you tell me the equation of the transform function, please? Anyone?
So number one, I see is a reflection over the x-axis, so it's going to be negative.
Perfect.
It's interesting to see.
Negative x, correct. Then what? The graphs are not congruent. That means there is a stretch or a compression. Now, when there is a stretch or a compression, I will say go with guts that it is always vertical stretch or compression. Think like this, unless and until it is specified in the question. You get the idea? Make it vertical. Now, what is the stretch factor? How much? This was 1 unit away, and this is how many units away?
3.
So it is a stretch factor of 3. Do you get the idea? Immediately we got the stretch factor. Now let's go to the translation. What has really happened? After the reflection, it moved 1 unit to the left. Is that clear to you? Since it moved 1 unit to the left, it will be x plus 1 square. Is this clear to you? And that is how we get our equation. So we have incorporated a stretch factor also and still got the equation very easily. And you now have an idea, how did we do that, correct? Now, let me give you one more key thing to consider. The point at origin, 0, 0, right? So if I multiply 0 by anything, you will get 0 only, correct? That is to say, if you could compare what happened to the 0, 0, the origin point, then you get what? Translation. You get the idea. You get translation by checking the two values, image of the origin point. Do you see that? So it moved 1 unit left. So therefore, you know it is a horizontal movement and the function therefore should have been written as x plus 1 squared. You get the idea. Comparing the point which was there at the origin to this image gives you translation. And definitely shape change means a stretch or a compression. So we can find the stretch and compression by comparing the 2 points, and one is a good factor. At one, what happened? So directly we get the multiplication factor. You get the idea. So at one it was 1, now it is 3. Done. So it is 3 times. You already got minus because the orientation was different. You get the idea, right? So this is how from the graph we can easily get our equation. Now, you should also, when you go through this video once again, write down domain and range of the transform function. Is that clear to you? So that will give you more practice. Domain and range of the transform function. Next, Akshit, can you please read the question?
Yes, sir. The graph of f of x equals to 2 to the power of x has been translated horizontally. Describe the transformations and find the equation of the transform function.
Tell me what is the transformation and what is the equation of the transform function?
Sir, it looks like the original function has been shifted to the right.
Yes.
And yeah, it looks like 2 units to the right.
Correct. So equation will be?
2x minus 2 in the exponent.
Perfect. Is that clear to you? So simple. So we have to just see, and we are given that's only a horizontal translation. Then check horizontal like this. Do you understand what is the movement? How many units it has moved? And that goes into the exponent in this particular case, and you have the answer. Correct? That is how you're going to do it. Next question, Vishruta, I'd like you to read the question, please.
The graph of f of x equals 2x has been transformed vertically only. A. Describe the transformations. B. Find the equation of the transformed function.
Can you tell, when I say transform vertically only, it could be vertical translation, it could be vertical stretch or compression. Remember that part. Is that clear to you? Now tell me, what kind of transformations are there? The red graph.
I see that there's been a reflection on the x-axis.
So that gives you minus outside. That's correct. What else?
And translation of 1 unit down.
2 units. This comes minus 2. Is that clear? And how about the vertical stretch? Can you tell me the vertical stretch, please? Very important. Compare this point.
Three units.
Is that clear to everyone? This was not an easy question. But simply because we have understood the concept, we are comparing what happened, right? So you're comparing with the horizontal asymptote. How far away are you from the horizontal asymptote, correct? So you went down 3 units. So that is how minus 3 comes in between there. So that is how you're going to give the equation from the graph, right? And of course, you can write down transformations, domain and range and all those things, correct? Now, Mohammed, please read this question.
The graph of f of x equals 1 over x has been transformed as shown in the red graph. A. Describe the transformations, and B. Find the equation of the transformed function.
Tell me, is there any reflection? No reflection, right? Both are in quadrant, same quadrants, correct? So they are in quadrant 3 and in quadrant 1. If there would have been reflection, they would have gone to quadrant 2 and 4. So no reflections. Perfect. Now, we are saying that there is transformation, and we are not saying what type of transformation. So in reciprocal functions, what you need to do is check the horizontal and the vertical asymptote, right? You see, earlier this point was not in the domain, correct? 0 was not in the domain. And now, which point is not in the domain?
1.
1.
1 is not in the domain. So 1 is not in the domain. Therefore, and origin means you know the horizontal or a vertical translation, correct? Because stretches cancel out with zeros. So that means there is only one horizontal translation of 1 unit, correct? And in that case, my equation will be x minus 1, Mohammed, right? We moved 1 unit to the right, correct? Second thing which you need to figure out is these are not congruent graphs, right? Red and green graph, you can see they're not congruent. There is a stretch factor. We will assume vertical stretch. If we assume vertical stretch, then tell me, what is the stretch factor? Now compare the 2 points, the green and the purple point given to you. The green point is at 1, 1, and the purple point is at 2, 2. How do you get the vertical stretch?
Factor 2.
2. So it is a factor of 2, and clearly that comes in the numerator, and y equals to 2 over x minus 1 becomes the equation of this particular graph. Is this point clear to you? Got it? Mohammed, is it clear?
Wait, you got the 2 because the purple point was sitting on 2?
Yeah, because that point moved to 2, right? Times 2. Y value increased by 2. So if you look from the origin, then what really happened to this particular point is once you moved 1 unit to the right, it went 2 up. Correct? The x value moved 1 unit right, and the y value moved 2 units up. 1 more unit up. Correct? But since the shape is different, both are not translations, there is a stretch factor. Do you get the idea? So if you do 1 plus 1, if you write this as 1 over x minus 1 plus 1, it will be wrong. Do you understand? That is what I'm trying to emphasize, which could be one of the options in a multiple choice test paper. Since the graph are not congruent, there is a stretch or a compression. We will assume vertical stretch. You could do it by compression also. So we'll assume vertical stretch. It is easy. And by comparing the two critical points, we found that the point which was at 1, 1 has actually moved to 2, 2, correct? So this one I understand, the point is 1, 1. The x value plus 1 gives me 2, right? But the y value from 1, how do I get 2? Times 2, right? 1 times 2. So I have stretched by a factor of 2 and got 2 in the numerator. Is this clear?
Sir?
Yes.
So technically, can you divide like the bigger y value by the smaller y value to get the factor?
Yeah, in this case you could, because the value was 1, that is why. You could do that. The other thing was, I could write a general equation. I know there is a translation of 1 unit from the asymptotes, correct? So I could write the value a here. Is that clear to you? I don't know what is the stretch factor. Now, I know the point 2, 2 is on the graph. So I'll substitute 2 for x and 2 for y. So I'll write 2 equals to a over 2 minus 1, which is a over 1. That means a is equals to 2. Simple as that. So this is algebraic method to give you the solution when the second point is given to you. Is that clear to you? So finding a point on the graph helps us to get the a value. And that gives you exactly, precisely what the function could be. Hamza, is this clear to you?
Yes, yes.
Okay, very good. Next graph, Hamza, please read the question and answer.
The graph of f of x equals to square root of x has been transformed as shown in the red graph. Describe the transformation and find the equation of the transformed function.
Tell me, what is the transformation?
Okay. I don't see a reflection. No translation either. I think it's vertically stretched.
Okay, vertically stretches one thing, correct? Reflection. There is a reflection on the.
Wait, I'm just confused about one thing. Can you define the x, like the line at the x? I can't really see it.
X-axis and y-axis?
Yeah, yeah.
Oh, these are numbered y-axis.
Oh, okay. Makes
X-axis.
sense.
Is it clear now?
Yeah.
Okay, good. Now tell me. So there is a reflection on.
Okay, yes. Now I see it.
Right?
Now I see it.
You see it, correct?
Okay.
And therefore minus outside, and we have square root x, right? We are writing big and bold. Tell me, origin point went where? From here it went what?
The
Left.
origin,
Left how much?
2.
1 unit left. It went.
1 unit left, and then
So I'll write x plus 1. And how much up? 2 up, right?
2 up. It's at 0.2, so 2 up.
Is this part clear to you?
Yeah.
1. Now we have to find the stretch factor, correct? Now, stretch factor, my way of doing it is like this. This is 1 unit, correct? In the original graph?
Yeah.
How much is this in this graph? From 2 to minus 1, it is 3 units, correct? So I get 3. But as I was saying, you could do like this. We found the translation very easily, comparing the origin, right? Where did the point on origin move? I got the translation. Now I don't know the stretch. I'm putting y equals to this. I know this point, which is for us, the y-intercept 0 minus 1, correct? So at x equals to 0, I get minus 1. So I have minus a 1 plus 2. Is it clear to you? I got this equation. I'm moving 2 to this side. So minus 1 plus 2 equals to minus a, which is equal to how much? Sorry, minus, I have to make it minus 2. Plus 2 comes on this side, right? So minus 3. And therefore, I get the value of a as 3. Do you see that? So I'll remove this a and write 3 here. So I could do this math also. Knowing a point, I'm writing a. For vertical stretch factor, we can figure it out algebraically. But from the graph also, you can figure it out that this step is a step of 3, right? And this was step of 1.
Yeah.
So the very first key point moved vertically by 3 units instead of 1, 3 times. You get the idea?
Yeah.
In most of the parent function, we have a very common point, which is 1, 1. Do you see? In half of the parent functions, we have 1, 1. This is an excellent point to find the equation of the graph, transformed graph, right? And the other point is most of the points go through 0, 0. 0, 0 gives you the translations. 1, 1 gives you stretch factor. Is this clear to you?
Yes.
Half of the graph have got these characteristics, and they should be solved in this manner as I'm explaining you, fastest and the best way of doing it. Is that clear?
Okay.
Yes, sir. So we know now we have actually discussed very difficult questions you will not realize till you see in the test paper and the response of other students. These were not easy questions, right? They involved a couple of transformations. Now, we'll look into domain and range of our function. Okay, Akshay, please read the question and answer.
Yes, sir. So what is the domain and range of the function g of x equals to minus 2 root of x plus 1 minus 3?
What is the correct answer? Tell me the domain range from the equation and then match.
Okay, sir. Sir, so first, I would see what transformations have been applied to the original parent function, right? So there's been a reflection over the x-axis.
Yeah.
Vertical stretch with the factor of 2.
Yep.
And the graph has been horizontally translated 1 unit to the left and 3 units down.
Like this,
Yes.
correct?
Yeah.
So tell me what is the answer?
So yeah, your domain would be greater than x is an element of real numbers such that it would be greater than or equal to -1. And your range would be y is an element of real numbers such that y is less than or equal to -3.
Correct. Now, from the choices given, which is the right choice?
So minus 1 to infinity, and I think D is the right answer, sir.
-1. Perfect. Square brackets means included. Square bracket means included, and the round bracket means not included. In square root function, you know this point is included, and therefore we are looking for the square bracket. Infinity can never be included. Now, this is also a convention of writing instead of set notation. You get it? Interval notation. Very fast way of writing. Correct answer. It means all real numbers within that given limit. Is that clear to you? So in the test paper, you can use this convention for writing domain and range. Is that clear? And you're
Yes,
absolutely right. And you're perfect. Your approach was perfect. I like it. Now, okay, Vishruta, can you please read and answer this question?
What is the domain and range of the function g of x equals -1 over x plus 2 plus 1?
Tell me.
A, the domain is x is the element of real numbers, x is not equal to
No,
0.
tell me the correct choice. Tell me first your answer and then we'll match the choice. Which one is correct answer, right? So better look at the equation, tell me what is not there in the domain, what is not there in the range, and then we'll just check with our multiple choice. Others can also look at it and then just tell me after Vishruta tells me the answer. Yes, Vishruta, tell me what is not there in the domain. It is a reciprocal function. It has horizontal and vertical asymptotes. And what is
There's
not
no
there?
0.
So x does not have what? From this
0.
equation. The restriction you have to look into the denominator, right?
Can I say something? X cannot be equal to 0 because then the function would be undefined.
No,
Or
no, no, no.
actually, never mind, because there's a plus 1.
Would it be -2?
Yes,
Is that equals
minus
0?
2. X is not equal to -2. That will make the denominator 0, correct? We have a vertical asymptote at x equals to -2, right? So that is not there in our domain. And what is not there in the range?
-1.
1. Because it will never be equal, this fraction will never be equal to 0, right? And therefore, it is never equal to 1, right? So that is our answer, that x is not equal to -2 and y is not equal to 1. It matches with option C. Do you get the idea? That is how we are going to answer. Is this clear to everybody? Is it clear, Mohammed?
Yes.
Yes, sir.
Very good, very good. So, okay. So let's move on to the next question. Mohammed, your turn now. Similar function for you. Tell me, what is not there in the domain? X is not equal to what?
The
Denominator cannot be 0.
-3.
Is it -3?
Yeah. And y is not equal to what? That is difficult. You have to just check the ratio of leading coefficients. 2 over 1. So y is not equal to 2 over 1 or it is not equal to 2. So we'll teach you in rational function how do we find the horizontal asymptote, right? This gives you the vertical asymptote and the horizontal asymptote in this case is y is equal to 2, right? So which is not there in our domain of range, which is not there in the range. So range y is not equal to 2. What is the correct answer? And x not equals to -3. I think that is the right answer, correct?
Sir?
Yes.
Sir, I just wanted to maybe take a guess. So you see for the horizontal asymptote, right, sir?
Yeah.
Can you factor 2 out of 2x minus 4, and then that would be your horizontal asymptote?
I'll give you this method just now. Probably I've written it here. Oh, it's gone on the other side. Okay. So how we do it like this. For fractions, see, we have 2x minus 4. I did take two common factor. Can you see the screen? X plus 3, right? Because x plus 3 is the numerator and denominator. So, but if you expand, you get 2x plus 6. We have minus 4 there. So I have to take away 10. And therefore, I could write this as 2 minus 10 over x over 3. And therefore, we could now say that the horizontal asymptote is 2. Okay?
Okay. Yeah.
So you could do what, Akshat, good try, very good method. This we could do, and we normally do it, right? But I'll teach you. In calculus also, we will be doing it. And the method there is like this. What we do here is we just take away 2x common, right? And what is left with? 1 minus 4 over 2x. I'm not canceling anything, writing like this. And denominator, we take x common. What is left? 1 plus 3 over x, correct? Is that clear? Everyone? Now the thing is, if x is approaching infinity, then what happens to 4 over 2x? In that case, 1 over x approaches 0, right? Because x is very large. So that means this particular factor approaches 0. We are left with 2x over x, correct? X and x cancel, we are left with 2. So therefore, y approaches 2. And that is how we are going to do it in calculus. Limits. First chapter. Do you see that? That is how we are bridging from advanced functions to calculus. This is our first chapter, limits in calculus. Okay, let's move on. Next question, please. Hamza, can you please answer this question? Read and answer.
So find the range of the function g of x equals to -3 sine 2x plus 1.
Yes.
Okay. So this is okay. So it's gonna go up and down and up and down. Okay.
Yeah. So tell me what is from here to here. That is your range, right?
Yeah.
Tell me, what is the range?
For a normal sine function, it would be 1 and -1, but I see this as transformed.
Mm-hmm.
I think it would be from -2 to -2.
No.
Oh.
Anybody else? Sinusoidal function is a new function. Let me explain you. When I'm saying 1, 1 is my axis of the sinusoidal function. I've just drawn this axis here, which is at y equals to 1. 3 is the amplitude. 3 is the amplitude. Amplitude means how much above the axis and how much below the axis. Same units, 3 units up, 3 down, right? So when I add 1 and 3, I get what number? I get number 4, correct? And when I subtract 3, I get -2. So that becomes my range from -2 to 4. Do you see that?
Yeah.
And we get option C as the right answer. So make a note of this. How do we find domain range when we have this sinusoidal function? Clear? So here there's a clean sketch on what I was telling you, right?
Sir?
Yes.
The method we just did for the sine function would also hold for the cosine function. Right?
Yes.
Okay.
All functions. So in short, the range or the y value will be axis minus amplitude to axis plus amplitude. Axis is this and amplitude is this, right? So just add them and subtract them. You get your answer. Okay? Axis is 1, right? So we have 1. I just add them. I'll write 1 plus -3, for example, right? 1 minus -3. Because it is negative, I did it bigger, the reverse way, right? Whichever number is bigger, that will come at the later stage, correct? And we get our answer. Is that clear? Mohammed, is it clear to you? Yes, Mohammed, is it clear?
Yeah.
Good. Okay, so now, Akshay, this question is for you. Please tell me the answer. Read and answer.
Yes, sir. Question 11. The point 26 is on the graph of y equals to f of x. Determine the coordinate of the image of this point on the graph of g of x equals to half f of -2x plus 1 minus 5.
Tell me.
So again, sir, what I would do is I would list the transformations and map it to how the xy would change. So it would be vertically compressed by factor of half. So that would apply to 1/2y and -5 for the y coordinate. And then for the x coordinate, it would be -half x minus 1.
Very good. Minus halfway. Do the reverse. Correct. You apply this to 2, 6 and tell me what is the point.
Okay, sir. So when you plug in 2 into x, you get -1 minus 1, which is -2. And then for 6, it would be 3 minus 5, so -2 also.
Perfect. Good answer. Everybody understood, right? Transformation of the points, and we get our answer, -2, -2. Vishruta, I'd like you to answer the next question, question number 12.
Find the range of the function. I think it's gonna be.
This is a restricted function. So we do have a parabola. Definitely the parabola is opening downward, something like this, correct? We have a parabola, but we are given you within a particular domain, right? Restricted. So don't think that all real numbers is the domain. No. Only a part of parabola we're talking about, whose domain is given to us from -4 to 4, correct? So I'm not asking your domain. I'm saying find the range of this function where the domain is from -4 to 4. Now tell me, what should be the answer?
Um, I'm not sure.
Anybody else?
Sir,
Hmm.
so how I would start it is I think I would factor out the half inside the bracket to
Okay.
find out the horizontal transformations, and
Okay, let's factor.
Yeah.
What do you get? X?
x plus
Plus?
2.
Very good. Where is the vertex now? From here you get the vertex.
Yeah, at
Vertex
-2
is
and 3.
-2 and 3. So we have a vertex of this, which is -2 is within this domain. Do you see that? -2 is within the domain. So we get -2 and 3, correct? So we have the maximum value. We know it is below this maximum value of 3, correct? Now we need to find till what value. And to find that, find the value of g of -4 and g of 4. Plug in 4 and -4 in the particular equation. See which is lower. Whether this point is lower or that point is lower. You get the idea. So you know that will be your range. Is this clear to you? So if I plug in 4, for example, then 4 plus 2 is 6. Half of 6 is 3. 3 square is 9. 9 times 2 is -18. -18 plus 3 is -15. And therefore, it seems correct. We already know that 3 is my upper limit, and that should be my answer. Is that clear to you? -15 to 3 becomes the range of this question. Clear? Now, this was actually a grade 11 question. You have done parabolas there, but nobody ever asked you such questions. Correct, Mohammed? Correct? So now, very important question. We are going to restrict domain and find the range. We may restrict range and find the domain also. Therefore, look at this question from the other side. If I would have given you the range, what could have been the domain? Think like that. And that is where it becomes slightly more tricky, right? Okay, let's move on. Next particular question. 13. Whose turn? Mohammed, read the question and answer.
Domain of the function f of x is 0, 10. Range of the function f of x is -1, 1.
Correct.
What is the domain and range of the function gx -3f bracket open x plus 3 back close plus 1?
Correct. Tell me. First, write down the transformation of points. What will happen to the x values? And what happens to the y values? Image point.
I know the vertex is -2 and 1.
No, it's not a parabola. It's a function. Any function. It is not a parabola. Is that clear to you?
Oh,
Any function. Now we have gone over that. Any function whose domain and range is given to you. Okay.
I'm sorry, can I just
Yes.
I
Yes.
just want to be sure, but for the x value, would you add 2, and then for the y value, would we multiply by 3 and then add 1?
Subtract 2. X. You do reverse. You
Oh,
get
okay, sorry. Because it was inside the bracket. Okay.
dy plus 1. That part is correct. Now tell me, this is the transformation. Mohammed, it's your question. Try to do it again. Domain. What happens to the domain? What happens to the 0 value? What happens to 10? And then what should be the domain? Tell me. This is the transformation. Domain, we have to look for x value. Is that clear to you? What happens to this? 0 will go to which place?
well, 0 will become
-2, right? And 10 will become -8, correct? Oh, sorry. 8, correct? Is that correct? So this point will go to, I shouldn't say point. The whole region, domain, changes from -2 to 8. Is that clear to? So we could be, this is the only answer. Okay, anyway. Range. Now tell me what happens to the range. 1 and -1. What happens to the range? Calculate.
wait. Why did 0 turn to -2 and the 10 turn to 8?
0 minus 2?
Is it because it's x plus 2?
No, yeah,
Oh,
yeah. 0, that is the transformation, right? X plus 2 means move left 2 units, correct?
what? So the range of the function is going to be 0 and the other one's going to be 2?
No, for the range, you have to calculate using y values changes. How does the y value changes? Minus 1 will, what will happen to minus 1? You have to multiply by -3 and add 1.
That's going to be plus, I mean, it's going to be 4.
Yes, and 1 will become?
1 will become -2.
So that becomes the range. You see that part? See? That is how you, now it's become complicated, right? We have given you domain and range separately, right? So domain changes the horizontal x value, correct? It gets translated. So let us say if there was a graph like this, something like this, right? So the whole graph shifted by 2 units as far as the horizontal thing is concerned. And that is how we got this. Is that clear to you? I mean, it shifted left. I shouldn't have drawn this one. It shifted left, right? 2 units left. Is that clear to you? So we got the domain part. And the range part is that it got stretched and flipped, right? So, and then we calculated these values to get our range. Is this clear? Okay. Okay, is that the solution for this question? Yes, see, yes. Now, next question, Hamza, can you please attempt this question? Similar
Okay. Yeah. So domain of the function f of x is 0 and 10, and the range of the function f of x is -5 and 5. What is the domain range of the function g of x equals to f -x plus 2 plus 5? Okay. So the x value, okay. So the x value would, okay. X value would be multiplied by -1, and you would subtract 2, and the y value would add, and the y value would add 5.
Okay, now here you have to first do steps, right? Always factor out negative,
Okay.
and then you get x minus 2. Do you get the idea? Plus 5. That is why I've put this question. Looks simpler than the previous one. It is more difficult. And so x value should have been added by 2. Is this clear to you? This is a mistake which should not be done in your test paper. Otherwise, you lose 2 questions. 2 questions, one on transformation and one somewhere else. 10 marks gone if you do this mistake in advanced functions. I'm not joking. Very clear. In grade 11, you lose 1 question, in grade 12, 2 on the same concept. So now tell me which is the correct answer. So 0 and 10 becomes what? What happens to 0? What happens to 10?
Okay, so 0 you would sorry, am I not muted? Okay, so 0 you would plug it into the -x plus 2. So 0 would become 2.
Yeah.
And the y value would become 10 would become 15.
Okay.
Right?
No. So first do domain. Okay. What happens to 10? 10. We are talking only about the
okay.
domain. Yeah, don't mix up.
Okay.
10.
So that would it would become -8.
Yes. So from -8 is lower, right? So -8 to 2, one of the options is there. That should be our answer. Now let's check range.
Okay.
Range is 5. Yeah, we have to add 5. So it becomes 0 and 10, correct?
Yeah.
-5. 0 to 10. So that works, right? So option A. Do you get the idea?
Yeah.
Correct. So 0 to 10 was for all of them because that was a simple calculation. But the x value, very difficult here. And that is how you will be doing it. Factor the.
Yeah, I forgot to. I just forgot to see. Okay, so you always have to factor every time you see something said.
Underline, never forget. Okay.
Okay, I want that.
Akshay, last question for you.
Yes, sir. So the domain.
Read an answer.
Yes, sir. So domain of the function f of x is.
Oh, Ankita, I never
-2.
asked any question to Ankita. Wait, because Ankita is not there on my screen. Ankita, can you answer question number 15, please?
Sure. Do you want me to read the question as well?
Yes.
Domain of the function f of x is -2 and 4. What is the domain of the function g of x equals -f negative 2x plus 1 minus 3.
Correct.
And so you would do the brackets, trying to sub in for x and y. It would be, since you said that we would lose marks previously, you would factor out the 2. Yeah, you're
Yes.
right. So 2 and then x minus half, bracket minus 3.
Yes.
Yeah, another bracket, then minus 3. So x would be, since it's negative x, would that be negative? Would that a negative be included into the x?
Yeah. What happened? I minus 2, I should have taken outside. Yeah, negative. Yes.
Yeah, so negative 2x
Ah,
minus, oh sorry, negative half x is a minus 3.
no, x value. What happens to the x value?
Wouldn't it just say negative half x then?
No, translation of half to the right plus half. You see
Oh,
the
okay.
x value?
Yeah, I get it now. Okay.
Correct. What happens to the y value?
Minus y minus 3.
Correct. Now tell me. Domain of the function is given to you. So we have to only work on the domain of the function, correct? So basically what happens to the x value? Is that clear to you? Tell me what happens
Yeah.
to the x value? Calculate. 2 minus 2 will become what?
Minus 2 will become 1
And plus half.
plus half. So 1 plus half would be 1.5.
And 4 will become what?
4 would become negative 2 plus half would be negative 1.5.
So that becomes your domain, right? 1.5 to negative 1.5. So what is the answer? Minus will be 1 plus.
I don't see, is it e? I think it says negative 2.5.
Oh, there is some calculation mistake we
Yeah.
have done on this part. Okay, correct. Good. So basically the value, has everybody understood this calculation?
Yes, sir.
So when you do minus half times 2, you get plus 1. Plus 1 plus half is 0.5 added. But when you do 4, then 4 gives you minus 2 and minus 2 gives you minus 1.5. And therefore, one of the answers should have been, it becomes from minus 1.5 to 1.5. Is that clear to you? Is that clear? So that should have been the correct option. So this is where we are going to end our today's lesson. Is this clear to you? Transformations. Now, I would like one of you to summarize your learnings for today.
Sorry, I just had a question real quick.
Yes, ask us.
Was this part of Unit 2, or have we not touched on that yet?
This is our Unit 1. Still, we are on Unit 1 itself. Unit 2 in your book is rate of change. And Unit 3 is polynomials, correct? But what I saw really was that while we were working on all these things, I thought there are a few things which should be absolutely clear before we move forward, okay? And therefore, what I did was that this is a chapter which is probably 1.4 or something in your case, right? There are 2 chapters in between. One is this, the other one is inverse functions, correct? Are you all absolutely clear about inverse function, or you have any doubts? How do we find inverse of a function? Mohammed, is this clear? Inverse functions clear to you, or you have doubts?
What, the inverse function is what, like a negative reciprocal or something?
No. Reverse calculation. But let me ask Hamza, is this inverse function clear to you, Hamza?
Yeah. I did that a lot last year. It was just swapping the x and y values and solving.
Yes, swap x and y. So
domain
I'm
and
actually,
range.
yes, I'm skipping inverse function. Is that okay? Because as we move forward, I will actually take up inverse function later, but I'm not getting into inverse function. But transformation helps us in finding equation from the graph, writing equation for the graph. There are so many places where the transformation will be required. And I've seen that most of the grade 11 students who come for advanced functions, they're not quite ready for it. And therefore, I discussed all these 15 examples one by one. I went very slow so that you all should understand that this is a foundation for us. Is that clear? So, okay. So, Mohammed, I would like you to summarize by telling me what have you learned today?
I learned like how to take the domain and range of like different types of functions. Um, yeah,
Okay.
that's mostly it. Yeah.
Hamza, how about you?
I learned how to find the stretch, the horizontal stretch, the translations of a function, and how to tell them,
Mhm.
and how to find the x and y value of a domain, kind of find the range in domain through that.
Perfect. Ankita.
Yeah, this was kind of like a review from grade 11 functions about the transformations. I did pick up on a lot of things like, for example, understanding the transformations using points. I remember doing the direct calculations rather than making a graph many times and then, graphing the transformations. So I felt like that way of doing it was much easier.
Mhm. Vishruta.
I didn't cover a lot of transformations, so this was very new to me, and I learned a lot about the equations.
Very good. You need to practice. So in the playlist, I have actually shared a couple of videos on transformations. So I'd like you to go through our playlist on MHF4U, and I'll also share those videos with you. You should go through them, right? Horizontal stretches and compressions are kind of tricky. So I'd like you to do more examples on horizontal stretches and compressions. Akshat.
Yes, sir. So this lesson was like a review of MCR3 once again. But what I found new in this lesson is that usually from like the grade 11 Nelson textbooks, when we look at the graph and try to find the equation, right, the graph isn't that clear. But in today's class, we really revisited that, and I learned how to actually get to the graph because usually the graphs aren't clear, so we just end up skipping the question. So that was really nice.
Let me summarize few key points which I want to emphasize. One is whenever you get a transform function, then within that square brackets, you have to factor out the coefficient of x before writing the horizontal translations. Is that clear to you? That can make huge difference. Second, when you look at the graph and you want to write down the equation from the graph, you look at the point which is kind of on the, which is the origin. Check what happened to the origin. Origin translations, or rather the image and the origin gives you the translations of the function. Do you understand? Because if there is any stretch or a compression, multiplying by 0 gives you 0. Therefore, if you check what happened to that point which was at the origin, it will directly give you horizontal and vertical translation. Is this clear? If the graphs are not congruent, that means for sure there has been a stretch or a compression. To make it simple, just imagine or assume that this is a vertical stretch. Write A for vertical stretch in the equation once you know the translations, correct? Put a point known from the graph to calculate the value of A. This is one way of doing it. Otherwise, if you get 2 points, which can be directly compared as a ratio, then you know A is those many times, correct? It's a factor. So in many cases, we check the point at 1, 1. What happened to 1, 1? 1, 1 become 1B. Then B is the factor. You get the idea? Then B is the factor. So that Y directly is a factor which gives us the answer. That if you remember these things, you should be in a position to answer all the questions related to graph in your area of advanced functions. Is this clear to you? Very important key issue. As we move forward, next class, we are going to start with polynomials, which is our unit 3. Rate of change we will do after doing polynomials. Is that clear to you?
Yeah.
So in case you get time, you please review polynomials from your book, plus try to do all the questions for unit 1 from the book. Yes, I have not covered inverse functions. Wherever there are difficulties, you can post those questions to me, correct? We'll take them up whenever we get the time. But inverse functions, we will do once again after doing polynomials, right? Okay, so we'll end our class here for now. Thanks for your time and all the best. Bye.
Bye, sir. Thank you.
Thank you.
Bye.